we are going to discuss about the undersampling to deal with the imbalanced data set. So undersampling are the different types. First is the random undersampling. In the random undersampling, what we do the sampling in a random way. It means if you see here we are removing the samples, so we are removing the samples in a random way, just picking the sample and removing. There is no any technique, we are in just random way we are using to remove the samples in the majority class. So here if you see, this is the majority class. Here I am making equal to with the help of this sample and making equal to the minority class. So this will have the 10, we can say, right? Here we have 100. After the sample I will get only 10 classes, which is equal to the minority. And after that we have to do the concatenation. It means these are your minority class, then again majority class, and make it the bytrain, this particular bytrain. So this bytrain we can use to train our machine learning model, this sampled output. Second method is the random undersampling with imblearn. Imblearn means imbalanced learning library. You can import it, and under this library we have the random sampler method. This will also work in a same way, in a random fashion. Here I am creating the object, then fitting just like a scikit-learn, then doing the training our input variable, then getting the output. It means sampled output. These sampled output we will use to train our machine learning model. If you see here, these are the output. It means 239, 239. Undersampling Tomek link. In the Tomek link, what we do, these are the minority classes, these are the majority classes. We create a link between the nearest of the minority classes and the majority classes. If you see here, these will be your nearest points. So we create a link between the majority and the minority. So we will remove the majority point between the link, and after that we will get only these particular points, right? Same thing, importing, then creating the object, then fit, then we get this particular output. Then after that, undersampling with the cluster centroid. Here we create the centroid in the majority classes. I select two centroid, these two, then calculate the distance of all the majority points from this particular centroid, right? Then after that we select only those majority instance which are closer to this particular centroid. These are closer to this particular centroid, and these orange are not closer to any centroid. So we will remove this particular orange point. Same thing, just like importing, then creating object, then fit, then we will get the sampled output. Next is the near miss undersampling. In the near miss undersampling, we perform in some steps. First step is select the minority and the majority. Second, select the distance between the minority and the majority. How do we calculate? In the third step, we select this particular point, majority point, and select the three nearest neighbor, 1, 2 and 3, because we have to mention the nearest neighbor, how many neighbors we are going to select. I am going to select only the 3. So 3, then what will be the distance? D1, D2, D3 divided by 3. It means average distance of all the majority points from the minority points. So this way we will get average distance of all the majority points. So all those majority points which will have the largest distance from the minority points, it means these instances have the largest distance from the minority points, those will be removed, and those instances which have the least distance, those will be retained. Here same thing, we are going to import, then creating the object, then training our object with the help of this particular input variable. Then we get the sampled output. It means 239, 239, right? Next is the undersampling with neighborhood cleaning rule. So in this cleaning rule, what we used to do, these are some majority samples I have. Okay, and these are the minority samples I have. So in the first step, I will select these particular majority and the minority samples. In the second step, we calculate the nearest neighbor. It means k and n, we select 3 in the second step. In the third step, we select the nearest neighbor for all the positive and the negative points. Let for this nearest neighbor would be 3. It means this is the correctly classified, right? It means we will not remove this. Let for this nearest neighbor 1, 2, 3. This is the incorrectly classified. If you see here, right, this is the incorrectly classified, so we will remove this. Now for this will also be incorrectly classified, so we will remove this. 1, 2, 3. This will also be incorrectly classified, so we will remove this. So this way we will remove all the neighborhood majority samples which are neighbor of the minority samples, right? It means most of the points will lie in this particular area, so these majority samples will be deleted. If you see, that's why I am getting 6354. Next, now I am going to apply the this particular sampled output to perform the classification. So first I am creating my base model with the help of logistic regression. Okay, creating the object, then training the object with the help of our original data set, then calculating the performance matrix. Here I am getting accuracy 96%, right? But if you see a recall is very come, it means 20%. It means out of 100 only 20 defaulters my model is able to detect. Okay, also precision is very less, and F1 score is also very less, right? It means it is not performing well. Now we will check the precision recall score. This is also very less, 0.27 between the precision and recall. Now I am applying the undersampling dataset. Here creating the object, then training our object with the help of sample data. If you see a near miss dataset. After that I calculate the performance matrix. If you see here, my recall is improved and F1 score is also improved for the positive classes, and for the AUC ROC it is also improved. So it means we can improve the performance with the help of undersampling.